Well, let's begin again so that we don't get you home after midnight. In this section, we're going to talk about different constituents of cannabis and safety issues. Once again, a number of you have come up and asked for contact information. It is on the slide, ethanrusso@comcast.net, and I would be really glad to hear from you. So, we've heard previously about the endocannabinoid system. It began with a plant called cannabis that showed us the way. It might have taken decades before we discovered the endocannabinoid system if people hadn't been studying this plant. And just to review, you've got the CB1 receptor, anandamide and 2-arachidonyl glycerol will bind there. Those are the endogenous cannabinoids. So, what about the plant? There are many different ways in which it's characterized and different names. In the Caribbean, ganja is named for what the Indians, unfertilized female flowers, the Indians brought to the Caribbean in the 19th century. There's several different kinds of cannabis on a chemical basis. We'll just talk about three. Type 1 is the more prevalent high THC cannabis. Type 2 was more common in nature before all the selective breeding for the recreational market happened. So roughly equal amounts of THC and CBD. And then type 3 plants, which have become much more important, particularly for treating epilepsy, are predominant in cannabidiol. Now, you'll hear a lot about so-called sativa and indica. There's debate about how many species there are. The way these terms are used in common parlance is really just total nonsense, and I would suggest that you avoid these terms. What we're really interested in is the biochemical content of the plant, and that's what we're going to be discussing. But it also would be good to have a description of its smell, its taste, and particularly what the effects are, what a patient can expect when they utilize it. This is a scheme that was developed by one of my colleagues at a company called NAPRO Research, and he has this very interesting report form called Phytofacts this has been patented. So he has these nice bars that show the amount of cannabinoids and terpenoids, the aromatic components that give cannabis its particular odor. How much THC versus CBD there is, a picture of the bud. And then in the third panel down, you've got these nice pictures with descriptions of the scent and taste. And in this instance, there are a couple of representative plants. You've got lemons and peppers, because limonene is in lemons and caryophyllene is in black pepper, and we'll discuss more about these. In the next panel on the right, you have the effects as reported by patients. And you see that this one's high in comfort and pretty good in energy. And then at the bottom, most interesting, and this is rarely reported even in the States, is the amount of each terpenoid component. The long yellow bar is limonene, which is very important as an antidepressant molecule. And the big blue bar is the caryophyllene, which is a CB2 agonist. It's working as an analgesic, painkiller, and anti-inflammatory agent that's not sedating or psychoactive itself. This is a picture taken from a book chapter that was just accepted for publication, hopefully out in a few months. And it lets you know that it's not just the unfertilized female flower that has important compounds that are therapeutic, but all parts of the plant have important uses medicinally, and this has been known historically too. And we'll go into a few of these. So first we have the phytocannabinoids. These are plant-based cannabinoids, and we've got about 12 here. We'll only deal with a couple in a lot of detail because we can't do everything in 4 hours. And we again appreciate your patience. This is the biosynthetic scheme of the plant, how it makes the cannabinoids. And we'll just look at some highlights. If you see in the middle at the top, geranyl pyrophosphate combines with olivetolic acid. In the plant, the cannabinoids start out in acid forms. They have an extra CO2 group that is eliminated. It's decarboxylated under the influence of heat or age. People often say that that activates the cannabinoids, but as we're going to see, these acid forms, as they're formed in the raw plant, also have medicinal uses. Interestingly, though, geranyl pyrophosphate is also a parent compound to the terpenoids. And so these compounds in the plant are actually half siblings. They're closely related. Let's talk about THC. As we've heard, this was not isolated and identified positively until 1964. It is what's called a weak partial agonist at CB1 and CB2. It means it is acting gently because synthetic cannabinoids are actually way too strong and produce a lot of side effects. In fact, THC by itself is too strong, and it really requires other components to what I call tame it to make it an acceptable drug. We know that it's an effective painkiller. It works on itch. It also is a bronchodilator. In the 19th century, there were cannabis cigarettes that were used to treat asthma. The THC was good. The smoke really wasn't so good, but that's the way they used it without knowing how it was working. On its own, THC has 20 times the anti-inflammatory properties of aspirin and twice that of hydrocortisone. It's a very prominent muscle relaxant. That's the mechanism by which it treats spasticity in MS, an approved indication in 29 countries. It's well known as an antiemetic, something that prevents vomiting with chemotherapy. It is, of course, the primary psychoactive component. And it does all these things without being a COX-1 or COX-2 inhibitor. The non-steroidal anti-inflammatory drugs affect those enzymes and as a result can produce ulcers, heart attacks, and strokes, which THC does not. It also can reduce beta amyloid, which is a toxic byproduct in the development of Alzheimer's disease. Now, cannabidiol, in fact, although it's less known to most people, requires several slides to describe all the things that it does. It was first isolated in 1940, but again, not positively identified until 1963. Interestingly, it hardly binds to the cannabinoid receptors in the usual site. But we know that even a small amount of it will interfere with the binding of THC. So just a couple of years ago, it was found out that it binds on another place on the receptor, what's called an allosteric site, and it makes it a little more difficult for THC to bind. Now that sounds like it might be a problem, but actually it helps reduce the side effect profile of THC, reducing the anxiety, reducing the rapid heart rate and panic that can happen with too much THC. It is what's known as a neuroprotective antioxidant. That means that it helps reduce the deleterious effects of brain trauma or stroke. And it's stronger in this regard than vitamin C or vitamin E. In fact, the US government had a patent on this effect, even though this is a forbidden drug with no reason. It's guilt by implication. CBD has no abuse potential, and yet because of where it originates, it's been vilified in this way. It is like chili peppers, capsaicin, the stuff that makes chilies hot. Cannabidiol does the same thing. And so either of these substances, when they're used regularly, can reduce neuropathic pain. And one of its most important roles is it prevents the reuptake of anandamide and thereby allows it to work longer, and also inhibits its breakdown by an enzyme called FA, fatty acid amino hydrolase. Contrary to popular belief, it is an alerting molecule. It's not sedating. As we've heard already, it's a very powerful anticonvulsant, anti-anxiety agent, and in high amounts, it's very powerful against breast cancer and a wide variety of cancer cell lines. It also acts against something called tumor necrosis factor alpha, which is an important mediator of disease in a number of autoimmune conditions such as Crohn's, ulcerative colitis, and rheumatoid arthritis. And again, not a COX-1 or COX-2 inhibitor. Back in 2005, it was not known how CBD worked against anxiety. I hypothesized that it may be working through serotonin. And in fact, we were able to demonstrate that it has a direct effect in high doses against working as an agonist, a stimulator of the serotonin 1A receptor. Actually, that is also the basis for its effects on nausea and a number of activities in the brain, and perhaps one of the reasons that it works against seizures. It also is anti-inflammatory versus another mechanism with adenosine A2A. And we believe that it could prevent progression of slow viruses. An interesting effect reported a couple of years ago is that it increases fracture healing time. It decreases fracture healing time and improves healing. Some misconceptions about it. A tiny amount is not enough. You need a large amount. It's a very versatile molecule. It's not particularly potent. Potency just means the amount you need to use, so it needs higher numbers relatively. People say that it's not psychoactive. It is. What it is not intoxicating. But when something is anti-anxiety, antipsychotic, and has all these benefits, clearly it is acting in the brain. I've already mentioned this one. It's not sedating. It gets labeled as such because a lot of kinds of cannabis that have CBD are also very high in myrcene, another component which is sedating. There is also a myth that this is legal in all 50 states. It's not. It is illegal in 50 states under federal law. There's also been a lot of controversy in the last couple of years. There were reports using simulated gastric acid that you could turn CBD into THC. I will just tell you this does not occur in the body. There were very artificial conditions under which they did it. This reaction's been known for 75 years. It does not happen. And this is just the natural history from the plant to the molecule. And you'll see in the bottom right, strong acid in the lab will cause this conversion, but it doesn't happen in your body. And this is from an article that just came out. And by the way, if I refer to an article with my name on it, I can send you any of these if you drop me an email. Now, this is called tetrahydrocannabivarin. It's just like THC, except it's got two less carbons than THC. So it's a 3-carbon side chain instead of 5. This was identified in 1970, but not much work was done on it until the last decade or so. It's an interesting molecule because it is an antagonist at CB1 at low doses and turns into an agonist, a stimulator at high doses. The main research on this has been as a treatment for diabetes and the metabolic syndrome, and it does reduce hunger and has benefits on some of the metabolic derangements of diabetes and related disorders. It's also a strong anticonvulsant, and it's also good against neuropathic pain. This has been in clinical trials, and hopefully we'll hear more about it later. It's actually quite rare in most Western types of cannabis. Analogous to it, cannabidiol with a 3-carbon side chain is called cannabidivarin. This is quite rare, but there are plants that have been bred by GW Pharmaceuticals that are very rich in either of these. And this is also proven to be an effective anticonvulsant. CBD has a broad spectrum of activity. This is actually better for what are called seizures of partial onset or focal seizures. So it's in phase 2 clinical trials right now. Now, back to the acid forms. So these are the raw forms of the phytocannabinoids. This is THCA, tetrahydrocannabinolic acid. It is anti-inflammatory, again, via this anti-tumor necrosis factor alpha mechanism. Then we've got something very strange. This was tested decades ago in rodents as an anticonvulsant. They found it was only effective at 200 milligrams per kilogram, a huge dose, totally impractical. However, Dustin and other people have noticed that even tiny amounts of this may take a situation where a child is in control with their seizures to a point where they are. And then there's some things we don't understand about it. It seems to bind to CB1, but it doesn't get into the brain normally. It doesn't pass this filter called the blood-brain barrier. However, we know that seizures and migraine break this down, and it's possible that it gets in people who have those disorders and might act that way, but this really needs to be worked out. It's also a very powerful anti-nausea agent. Cannabidiolic acid is what you get before CBD. So it is the predominant phytocannabinoid in fresh hemp. It's a natural herbicide. This one can produce COX inhibition, but only at very high doses. I don't think there's a lot of danger there. This is a very powerful antiemetic, good for nausea, and about 1/100th of the dose that's effective for CBD. Unfortunately, it hasn't been tested in humans yet. We also know, based on the historical and some anecdotal data, that this is probably extremely effective at treating tumors. There's been very little work done formally, but we know that fresh hemp on tumors works very well from the Copts in the 4th century. So again, sometimes what's old is new again. Now, on this page, taken from an article from several years ago, you'll see a bunch of familiar plants: lemon, pine needles, hops, lavender. These are all components that give those plants their characteristic aroma, and all of these occur in cannabis as well and contribute to the medicinal benefits. So some of these treat pain. Some are anti-inflammatory, some are mood enhancers, and many of them modulate particularly the side effects of THC and make it a more effective and safer medicine. So here are some of what are called the monoterpenoids. What they have in common is they're 10 carbon molecules. They have carbon and hydrogen, and a few of them have oxygen, but no nitrogen. And so you see them. This is a very busy slide. I was hesitant to take anything out, but we'll just hit some of the highlights. Pinene is very widely distributed in nature, best known from pine needles. It's very available on inhalation. We know this from workers in sawmills. It's a wide-spectrum antibiotic. It works on a wide variety, including MRSA, the multiply resistant Staphylococcus aureus, that produced an epidemic of hospital-acquired infections around the world, especially several years ago. Most noteworthy is that it is an acetylcholinesterase inhibitor. Acetylcholine is a memory molecule in the brain. THC is infamous for producing short-term memory loss because it is anticholinergic. This reverses that and helps prevent the situation where, what was I saying? That short-term memory loss. Additionally, this may be neuroprotective. There were experiments done in rats producing damage with hydrogen peroxide, an oxidizing agent. But the main utility of this is if you had a condition where you had to use THC every day and you had to work or study, you want some pinene in your cannabis to counteract that side effect. What we have in abundance, in contrast, is this one, myrcene. Myrcene is also in celery leaf. This is an anti-inflammatory agent. It is a muscle relaxant, but it's very sedating. It is what I like to call the couch lock factor in cannabis. If there's a type of cannabis that's high in THC and high in myrcene, the person's going to inhale it and they can't get off the couch. That's couch lock. Now, what's interesting about the pain-killing activity of myrcene is it's blocked by naloxone, the opioid blocker. So it helps explain its very narcotic effect. Some people like this, but there's positively too much of it in most types of cannabis that are available in commerce to the exclusion of other more beneficial components. So actually, we're breeding now to have less of this. In contrast, a very helpful agent is this, D-limonene from the familiar lemon, limes, any of the citrus will have this in abundance. This is a potent antidepressant. There was a clinical trial done in Japan where they wafted a lemon scent in the air on a ward full of hospitalized depressed patients, cut their depression scores in half and got them off of medicine. It also is immune stimulatory. It has been tried as a sole agent in treating breast cancer, not with great efficacy, but it might have been more effective if it had been used in conjunction with cannabinoids. It also works on the A2A adenosine receptor, and we currently are doing experiments to see if its combination with THC and or CBD are synergistic, and hopefully we'll have an answer for that for you in a couple of years. But that's going on right now. A new one, very exciting. It increases mitochondrial biogenesis. It increases the metabolic rate of the engine of energy in the cells, the mitochondria. And so it causes white fat, the bad kind of fat, and turns it into brown fat, which is more active and could be a possible obesity treatment. So I think we all need more lemon in our lives. Linalool is famous for coming from lavender, a very well-known anti-anxiety agent, also a great local anesthetic. I suggest that everybody keep lavender essential oil in their fridge for kitchen burns, because if you put it on neat and cover it with an ice cube, the pain will be gone in 5 minutes, and 10 to 1, there'll be no blistering. This is also a very powerful anticonvulsant, and it works against glutamate, that stimulatory neurotransmitter that often there's too much of. Dustin has a case that he wrote up that was recently published in which having a little bit of this made the difference between non-control and good control of seizures in a patient. So this is a very exciting development. There also are sesquiterpenoids in cannabis. These are 15 carbon molecules, and we'll only deal with one in detail. This is beta-caryophyllene that I've already mentioned, a component of black pepper. It's been long known that it's a very powerful anti-inflammatory. It has traditional use for pain and inflammation in South America. In contrast to most anti-inflammatories, it protects the stomach against ulcers. What was discovered by our colleague, Jörg Gertsch, in the last decade was that it is a strong, selective, full agonist at the CB2 receptor, the non-psychoactive cannabinoid receptor, and this is how it exerts its anti-inflammatory mechanisms. Now, that could be useful for many, many conditions. Treatment of pain, treatment for fibrosis in the liver, hepatic fibrosis. It also should be an effective treatment for addiction, such as to cocaine. This is a very exciting agent. It has no drug abuse liability, and hopefully it will be developed as a supplement as well as an important component of cannabis. And then we have what we call a few cannabis odds and ends. I tried to be clever when we named this book chapter, Cannabis Pharmacology, the Usual Suspects, and a Few Promising Leads. You're actually among the first people to hear about some of these promising leads. Let's talk about cannabis roots. Historically, these have been used since ancient times, but now we've got tons of this that people are throwing away or composting. What's interesting is there are no cannabinoids in the roots. Instead, you have things that aren't in the tops, such as triterpenoids. So these are 30 carbon molecules. One of these is friedellin. This is a very powerful anti-inflammatory that also has shown a lot of activity against a variety of tumors. Considering that there are metric tons of this available at little or no cost, somebody needs to be doing something with it. So this is an interesting byproduct. Another one is canoprine that's found in the leaves. And sometimes a decent amount. 0.2% doesn't sound like much, but if you've got tons of leaves that aren't being used for anything, this certainly could be extracted. It's a potential anti-inflammatory. It inhibits a thing called 5-lipoxygenase and really deserves a better look. Then we've got the hemp seeds. Normally, for medicinal use of cannabis, you want the unfertilized female flower. However, hemp seeds are very nutritious. It's a very complete food. It has essential fatty acids that you can't find elsewhere. It has a very healthy, digestible protein called edestin. I actually have these in my cereal every day. Then we have hemp sprouts. There is an agent that was first described 3 decades ago by a friend of mine, Marilyn Barrett. Canflavin is what's called a flavone. You see the molecule here. This will never be developed as a drug on its own because it's too hard to separate from its close relative, canflavin B. It was noted that this was a powerful anti-inflammatory, 30 times more powerful than aspirin, and somewhere between it and dexamethasone, a steroid. A couple of years ago, it was found that when you sprout the seeds, you can produce a good amount of canflavin A without any cannabinoids. So this could make an excellent supplement because it has a really interesting anti-inflammatory profile. It works against prostaglandin E2 and this thing called MPGES. And so it's got a profile that's felt to be ideal because there's no COX-1 or COX-2 inhibition. So it should be strongly anti-inflammatory without the liability of those drugs. So very promising. Now, I want to go back to these phytofacts and give you some examples of how specific chemovars, chemical varieties of cannabis, could be used. This is a type 1 plant. If you look in the second panel, it's almost all THC. However, it's got a large amount of green, the pinene, and a good amount of blue, the caryophyllene. So this is going to be good for conditions where you need THC, like in spasticity and pain, but with a clear head. So the person who needs to work or study could take this during the day and likely get a good effect. This is a type 2 plant, roughly equal amounts of THC and CBD. It also is high in limonene, the yellow bar. It's high in linalool for its anti-anxiety effects and local anesthetic effects, and it's high in caryophyllene. So this would be quite good to treat burns and epilepsy, two very, very different things that potentially could be treated by the same single type of cannabis. This is a type 3 plant, so it's cannabidiol predominant. Very little THC at all, a little bit of limonene, a very marked amount of caryophyllene. So this should be quite good to treat pain, inflammation, and addiction. Both CBD and caryophyllene have anti-addictive effects, and we don't have time to go into all the details, but I can sure send you papers that document this. Another type 3, CBD predominant, called lemon CBD because of the high limonene along with the CBD, and we think that this would be very good to treat depression and anxiety. The whole area of psychiatry has been ignored for the most part in clinical trials, with the exception of 2 clinical trials in schizophrenia with cannabidiol that have both been positive. Another type 3 plant, very interesting. It's got high cannabidivarin and cannabidiol, also high in limonene, caryophyllene, and linalool. So I would expect this to cover just about every kind of seizure there is. It might be even better than any of the available conventional drugs. Now, this is to demonstrate what selective breeding can do. What we have here is, from left to right, a type 1 THC plant, type 2 THC and CBD equal, and type 3 CBD plant. But look at the bottom. The terpenoid profiles are identical. This would be an ideal way to compare these. Patients could try them sequentially to see what worked best and really see the differences when the terpenoid profile remains constant. So what do? The questions would be, does CBD chemovar, does it last longer? And the answer is yes. This is one of the effects of CBD, is it makes THC last longer. So it delays the peak effect of THC and prolonging the overall benefit. Now, let's talk about safety. The most common way to use cannabis is smoking, but this really isn't the best way for medical applications. This is illegal in most jurisdictions. Even in places where cannabis is legal, you're often not allowed to smoke in public. It's very quick, but it's the most likely to produce intoxication or reinforcement. People say that it's easy to adjust the dose, but with high-potency material, the chances of overshooting, even with one inhalation, are a significant problem. It actually is a very inefficient way. It wastes THC, the side stream smoke or burning it up. It does produce polyaromatic hydrocarbons that are potential carcinogens. Cannabis-only smokers do not develop lung cancer. However, in many areas of the world, it's still used with tobacco, and that does. It does produce cough and bronchitic symptoms, and it's unlikely to be an approved medicine by this vehicle much of anywhere. Just a comparison of the effects. What we've got in the blue is smoking cannabis, and then very close by is vaporizing THC. And then in the green, we have the comparison of using an equivalent amount of THC, but by an oral mucosal administration, sprayed in the mouth. What you see with smoking or vaporization is these very rapid peaks that come down very quickly. This quick up and down is going to produce a lot of psychoactivity. It's also going to not last very long. In comparison, when it's administered oral mucosally, it's slow and steady. you do not have the same level of side effects and a much more prolonged medicinal benefit. These are studies of Sativex. At the top, we see what happens with people with chronic, stable symptoms, the number of sprays a day over a year and a half. Now, you've heard before how with opioids that frequently to treat pain, you've got to use more and more over time. This is not the case with cannabis-based medicine. You see that not only does the dose stay steady, it actually went down a little over a year and a half because the medicine stays effective and often becomes more effective. And the bottom panel, what we've got is measures of intoxication. This is on a scale of 1 to 100 or 0 to 100. 20 is you feel something, 80 is I'm high. That's the aim for the recreational user. You see with Sativex, there isn't much different from placebo. You're in the low single digits. So it is certainly possible and advisable to have a low enough dose to treat the symptoms effectively without the need for intoxication or similar side effects. If we look at pooled data of a bunch of different cannabis-based medicines and what they do, the side effects are predominantly in the nervous system, psychiatric and neurologic. This is not a surprise. The anxiety, the panic, the freaking out. Those are the most likely, but those are avoidable with the right dose and the right preparation. So we see the central nervous system effects, anxiety, euphoria. I won't argue that's a side effect, although the Food and Drug Administration thinks it is. Decreased muscle tone, heightened sensory perception, decreased short-term memory, etc. Decreased body temperature. If somebody has too much THC, they may shiver because it lowers the set point in the brain. Now, the most important side effect outside the central nervous system are effects on the heart, rapid heart rate, and particularly with very high doses, what's called orthostatic hypotension. If someone inhales a dab, a high-potency THC material, they may suddenly faint. Their heart is not beating fast enough to get blood to the brain. They pass out, but they may be seriously injured on the way down and end up in the ER. So that's a serious but avoidable side effect. This is a study comparing, this is with old data, but these are patients using Sativex, the cannabis-based medicine with equal amounts of THC and CBD and some terpenoids on a chronic basis compared to patients getting government-approved cannabis in the Netherlands and in Canada. Again, many months of treatment. So the smoked cannabis is in the warm colors, the orange and red. The cool colors are Sativex, and you see in every instance that the side effects are much higher with the smoked cannabis, with one exception, and that's dizziness. But this was done in studies prior to about 2005, where very high doses of Sativex were used with a very aggressive titration schedule, rapid increases in dosing. In comparison, later studies use lower doses and more slowly applied, and you see that dizziness that was 32% comes clear down to about 14%. And all the other common side effects like fatigue, sleepiness, nausea, dry mouth are cut in half just by lower dose and starting more slowly. Something I want to emphasize, because this is a problem you can avoid. It'd be my hope that you have a cultivation program in the future, but you must be in a position to avoid use of pesticides. A study done by Sullivan et al. A few years back, they took cannabis material, they put pesticides commonly used or found in cannabis on it, and put it on a smoking machine to see how much they could recover, and it was somewhere between 40 and 70%. Well, that's bad news. I live in Washington State, where cannabis is legal, but in the legal market, we decided we'd do some testing, and this was done last year. 26 samples were used. Most of them were cannabis concentrates because that's what kids buy in the recreational market in the States. These were witnessed, sent to a state-approved lab in another city in Washington for analysis. What we found was very sobering. 85% of the samples in the legal market were positive for pesticides. Most of them had multiple different ones and in huge amounts, hundreds of thousands parts per billion. There were 24 different agents, and they were from all kinds of chemical classes, really bad stuff, including neonicotinoids, which kill honeybees. It may be that we're not going to have apples and other crops in North America in the future if we lose all our bees. This is from the article that we published in relation to this. Again, I'd be happy to send you. These are the 24 insecticides. We'll just look at one. This is carbaryl, carbamate insecticide. It's what's known as a bad actor, which is a way of saying that it has toxicity of a severe nature in multiple different systems. It is a cholinesterase inhibitor. Unlike pinene, which is weak, this is very strong, so much so that it'll produce convulsions in anyone. And keep in mind that kids with seizures might be getting this if their parents bought the wrong kind of cannabis. It is a carcinogen. It's also a developmental and reproductive toxin and a suspected endocrine disruptor. In a particular sample, there was 255 times the expected allowable amount that might be used on a non-food crop. None of these things have ever been tested, let alone approved, for a product that's meant to be inhaled. Now, smoking, I've already said, is not the best way to use cannabis. Better is vaporization, the idea being that you boil the cannabinoids and terpenoids off without burning the material. What we've got here is vaporization at different temperatures, going from the untreated dried cannabis to vaporization at 175 degrees Celsius, 195, and 230 degrees, where it's toasted but not quite burned. Unfortunately, even no study of vaporization to date has shown total elimination of these polyaromatic hydrocarbons, the potential carcinogens. Additionally, it does not eliminate ammonia, a toxic byproduct, which will be found in cannabis that's grown with synthetic fertilizers. So this remains problematic. There are other ways to use it, however, beyond the buds with the funny names. There are cannabis confections. The authorities hate these because they could obviously be attractive to children. We have sprays in the mouth that are supposed to be like Sativex. So there are different ways it can be used. And of course, we have the concentrates. A survey was done several years ago, and this was worldwide, done on the internet. And there were some interesting things. Most people who use cannabis medicinally still preferred to smoke it. And even though people had tried vaporizers, only about 27% preferred them, which was unfortunate. At the time, few were using it orally or as a tincture. These might be a little different now, particularly in the States. We've had, again, this profusion of concentrates. They're really convenient in vape pens. They don't smell. The terpenoids are usually eliminated to the benefit of THC, and they're easy to use, and they're really not a good medicinal preparation. So we've had this trend over time to produce more and more THC. Even in the olden days with sieving of cannabis to just get the trichomes where the THC is produced, you could get up to about 60% THC, but that wasn't enough for some people. And so now we have concentrates, what's commonly used dabs. This is a study where they used different things to extract. Olive oil turned out to be good. They didn't try coconut oil, but that is a really good way of extracting. However, what's really most common in the States is flammable solvents like naphtha and butane, which are both contaminants, leave toxic residues, and are highly explosive. For people who use these dabs, even they will admit that they develop tolerance, they have to use more and more to get the recreational effect, and not uncommonly will have some withdrawal symptoms that we almost never see in lower dose medicinal doses of cannabis. But over 50% of sales in Washington State now are these concentrates. The question I'd ask is, how high does a patient need to be to treat their symptoms? And the answer is they shouldn't have to be high at all, or rarely so. And so this is a point I would like to emphasize. Now, there are additional problems. Commonly, these come in these vape pens. You have this product you see in the second panel they call wax because it looks like it. It's a tarry substance. You have the unheated coil, and then when you press the button, it's red hot in seconds. And I guarantee that isn't vaporization, that's burning. So you again have the potential of producing toxic byproducts. And we know this for sure. This was a study that was done with vape pens using tobacco, but some of these use the same propellants that they use with wax to make it easier to use. And these are propylene glycol and glycerol. A lot of these units, when they're overheated, will turn those into formaldehyde, which is group 1 carcinogen. It's the same thing they use to embalm bodies. The authors of this experiment thought that the risk of getting cancer this way was actually 15 times greater than with chronic cigarette smoking. So if someone is going to use a vape pen, the advice would be that they should not use one at too high a temperature and not with these propellants that were never designed to be heated and inhaled. They're safe for oral use. I think this might be our last slide. I wanted to emphasize this, the concept of land races. Cannabis came originally from Central Asia, but for sometimes hundreds of years, it's been grown in a local environment. When that's the case, it becomes well adapted to that locale. And often these types of cannabis have very interesting attributes. Unfortunately, these land races around the world have been lost. In Jamaica, the old-time ganja has been replaced by seeds from California and the Netherlands, I think quite to its detriment in quality. But the same thing is true in Colombia and in Morocco, Afghanistan, and Thailand. So a lot of well-adapted traits and medicinal effects have been lost. I don't know if there are land races on Cayman, but certainly you have the potential for ones that grew in Jamaica to be used here in a similar climate. You don't have the elevation that they do in the Blue Mountains, but to some extent, there should be the possibility. So this is a genetic legacy that should be preserved if at all possible. And that is the end of this presentation, so thank you once again.